Okay, for our next example, it actually says g of x is equal to the square root of x squared minus 9. Okay, so again, we take my radicand, and again, as I rehearse, whenever you're taking the square root, fourth root, sixth root, or any even root of a radical, you want to consider those values of x that will make your radicand, which is the inside up under the radical, that will make it non-negative. Those are the things that we can actually take square roots, even roots of. So what we do is we take x squared minus 9, and we say, where is this greater than or equal to 0? You know this is a difference of two squares that factors as x plus 3 and x minus 3. And so if you recall that when we solve these, we now take our test points of -3 and +3. Our test points will be those values of x that will actually produce a value of 0 here. Okay? So we need those in order to partition the real line to see actually where would this thing be non-negative. So we have both factors of x plus 3 and x minus 3. If I try a value to the left of -3, like -4, I have -4 plus 3, that's negative. -4 minus 3 is negative. If I try a value between -3 and 3, like 0, 0 plus 3 is positive, 0 minus 3 is negative. And anything to the right of 3, like 4, 4 plus 3 is positive, and 4 minus 3 is also positive. So we see that a negative times a negative here will produce a positive times a negative is a negative, and a positive times a positive is a positive. So our solutions here, because what we wanted those values that are greater than or equal to 0, my domain here now will be, the domain is the set of all x such that, okay, now x is, what we want to put here is that x is greater than or equal to, okay, this is not right. Oh, excuse me, this is not right. Let's write this in interval notation. Here, we would say that my domain, and I apologize for the mistake, the domain will be from minus infinity up to -3 with a bracket, because we also want the value of 0. And we know that -3 will give me a value of 0. Union 3 to positive infinity, close parentheses. And so that's how we would write actually our set builder notation. Now, if we wanted to write set builder notation, we would say the set of all x such that x is equal to this interval, or x is equal to this interval. Or we can say and, because and is going to include both of those. And I apologize for being spotty with my teaching. But the domain here consists of all of these values together, all of those values.